All right, today we're diving into what is probably one of the biggest, highest stakes battles in all of tech. It's a war for the future of AI hardware. You've got the undisputed king, Nvidia, on one side, and on the other, a quiet but powerful revolution being led by Google. This, right here, is the fight for AI's next frontier.
You know, for years when you said AI, you basically meant Nvidia. They built this incredible $3 trillion fortress by powering the training of huge models like GPT-4. But here's the thing, that might just be chapter 1. The real story, the one that's going to define the next decade, is happening right now, mostly behind the scenes.
And look, let's not downplay it. Nvidia's dominance is absolutely staggering. Right now, they control over 80% of the entire AI chip market. Their GPUs became the engine of the AI revolution, and it's made them one of the most valuable companies on the entire planet.
So, let's start with the reigning champion. Nvidia's success, really, is built on one core thing: AI training. They didn't just create the hardware, they also built the entire software ecosystem that made today's AI even possible.
And this is the critical point, the real twist in the story. The very revolution that Nvidia started is now creating a brand new problem. A problem its own hardware isn't perfectly designed to solve. And that right there is creating a massive opening for a new contender. So let's talk about the dirty little secret of the entire AI boom. The absolutely astronomical cost of actually using AI models. See, it's not about training them anymore. It's about running them. And it's an economic crisis that is quietly reshaping the entire industry.
To really get this, you need to understand the difference between training and inference. Think of it like this. Training an AI model is a one-time, incredibly intense sprint. It costs a fortune, yeah, but it's a single event. Inference, on the other hand, that's the marathon. It's every single time you ask ChatGPT a question, every time you generate an image with Midjourney. It is the cost that never, ever stops. Now, this is where it gets really mind-boggling. The sheer scale of the cost difference is insane. Over a model's lifetime, just running it, the inference part, can cost a staggering 15 times more than it costs to train it in the first place. You know, for a company like OpenAI, that's like a $150 million training bill versus an annual inference bill of over $2.3 billion.
And this chart really just shows you where all the money is headed. By 2030, the entire market for AI compute is expected to be dominated by inference. We're talking 75% of a massive $255 billion market. So yeah, training gets all the headlines, but inference is the real economy. The only question is, who's going to build the engine for it?
So this brings us right to the heart of the conflict. The chip that was perfect for that training sprint isn't necessarily the right tool for the inference marathon. Let's look at the two completely different philosophies written in silicon.
Here's the best way to think about it. An Nvidia GPU is a generalist. It's a powerful, super flexible Swiss Army knife that can do a lot of things really well, from playing video games to training AI. But Google's TPU, their tensor processing unit, it's a specialist. It's a scalpel, designed from the ground up to do one thing with brutal, breathtaking efficiency: the math that's at the heart of AI.
And that's because TPUs are what's called an ASIC, an application-specific integrated circuit. Now, that's just a fancy way of saying its circuits are physically hardwired to do the specific math that AI relies on. It strips away everything else. It basically trades the GPU's do-anything flexibility for raw, focused power. And when you put them head-to-head on the stuff that really matters for inference, wow, the difference is stark. As you can see, TPUs can deliver up to 4 times better performance for every single dollar you spend. And then there's power efficiency. They use 60 to 65% less energy. For a massive data center running millions of queries, that's not just a little saving, it's an absolute game changer. Okay, so this isn't just theory, this isn't a what if. The biggest and smartest AI companies in the world are already voting with their wallets and their workloads. A massive migration from Nvidia's GPUs to Google's TPUs for inference is happening as we speak. And yeah, we're talking about the heavy hitters here. Midjourney, the AI image giant. Anthropic, the company behind the Claude AI models. Even Meta, one of Nvidia's single biggest customers. They're all moving huge chunks of their inference workloads over to Google's TPUs, because the economics of running them on GPUs are just becoming unsustainable.
And you don't have to take my word for it. Just listen to this quote from Midjourney's CEO. The results were so dramatic, so immediate, that the entire cost of the migration project was paid back in less than 2 weeks.
That is the kind of economic incentive that forces an entire industry to change course.
And for Midjourney, what did that actually look like on their monthly bill? A 65% reduction in their inference costs. Just think about that. For a startup, that's not just an optimization. That's an existential extension of their runway, of their ability to scale.
But come on, this is Nvidia we're talking about, a $3 trillion empire. They are not just going to stand by and watch this happen. They have a formidable defense and a pretty clever counter strategy already in motion.
So, here's the trillion-dollar question, right? Does this big shift to inference mean Nvidia is doomed? The short answer is absolutely not. They have some incredibly powerful defenses.
First off, there's CUDA. That's Nvidia's 15-year-old software ecosystem that pretty much every AI developer on Earth knows how to use. It is a deep, powerful moat. They're also not standing still on the hardware front. Their new Blackwell chip is designed to be much more efficient at inference. But their most clever move might be a completely new strategy altogether.
They're calling it disaggregated inference, and it's actually brilliant. They realized that an AI's response happens in two stages. There's a pre-fill step that needs a ton of raw compute power, and then there's a decode step that needs a lot of fast memory. So with their upcoming Rubin architecture, they're creating different specialized chips for each step. It's a really smart way to make their general-purpose hardware act more like a specialist, directly taking on that cost problem.
So, what does this all mean for the future? Well, this battle between the Swiss Army knife and the scalpel, between the incumbent king and the quiet challenger, it has huge implications for pretty much everyone in the world of technology.
If you're a startup, cheaper inference democratizes the field and lets you actually compete with the giants. For enterprise CTOs, choosing the right chip is now a massive strategic decision that could save your company millions. For investors, it signals a potential threat to Nvidia's sky-high profit margins. And hey, if you're a developer, it means learning new skills like JAX to work with TPUs could be a major career move. So at the end of the day, it all comes down to this. The next phase of the AI revolution isn't going to be won by the chip with the most raw power. It's going to be won by the chip with the smartest economics, at a planetary scale. As the entire world shifts from that one-time sprint of training to the endless marathon of inference, a new war for the soul of AI compute has just begun. And believe me, the winner is far from decided.